Assalamualaikum and a very good morning. I bid to the all lecturers. So today I want to present about my final year project 1, which is the development of the next collector of edible bird nest, coEBN. So I am Nazatu Shahira binti Aziz, and the main supervisor of my project is Sir Khairul Amri bin Tofrawi. This is the project contents, which is consists of several parts, which are problem statement, objective, scope of study, and lastly the methodology. For your information, in Malaysia, the edible bird nest called by name sarang burung walit. So now we move to the problem statement. Okay, the first problem statement is there is no specific equipment because no companies provide the right tools tools to help the process of harvesting of the EBN. Okay, next, the current equipment does not meet the harvester requirement because they need the multifunction tools, which is consists of scraper, mirror, and adjustable stick. Okay, lastly, they are facing the problem of energy and time consumption because it can be proved by the statement by Mayans in 2015, an investigator from the United States, that they state that they use the leather and scraper to harvest the bird nest, but they need a large number of workers because the process requires a lot of energy, while maintaining the quality of the bird nest. Okay, next, the objective. The first objective is to design the multifunctional tools for harvesting bird nest, namely next collector of edible bird nest, Wallet coEBN, by integrating the function and the features required for the harvesting activity. Second objective is to fabricate working prototype concept of coEBN at an affordable cost. Now we move to scope of study of this project. So this coEBN suitable for birdhouse structure with a range area of 20 times 40 and 30 feet height, because according to Mulia in 2008, it is the ideal sizing of the bird nest. Okay. Next, the scope of the study is the whiteness. It is because the species of the EBN, the edible bird nest, is white nest because it is the majority species of EBN. Next, this slide is show the next collector of edible bird nest, coEBN. This it show the rough view of the coEBN from the isometric view, the top view, the front view, and the side of the product. Okay, now we move to the methodology. So in this methodology, there is a flow chart. This flow chart show the process to fabricate this coEBN. Okay, the starting is collecting customer requirement through the survey. Next, designing the coEBN by referring the selected house of quality and the per method, and then draw the 3D model in SolidWorks and stimulate it through the SolidWorks also. Okay, for the prototype, it depends on the simulation. If success, it can proceed to the prototypes. If not, need to design the new concept based on the based on the house of quality and the method. Okay, now for the survey, the survey given to the resident of the Kampung Tagas-Tagas Beluran in Sabah because they have their own experience on this industry. They are for the survey, there are 3 sections of the survey. So now we will go through the section by the 3 section. Okay, this is the section A. This section A is about the demographic aspect, which include age, gender, level of education, employment, and the question that know about the Swiftlet industry need the appropriate equipment to undergo the harvesting season. Next, the section B, which is the market. It is a focusing in the criteria of the EBN house. So the last section is the section C, which is the product specification. Each question will have the 5-point scale arranged from the least to the most criteria. So we move to the house of quality of this product. Okay, house of quality is the important things in every designing new product, because based on the Ye Kiang in 2005, a customer needs a requirements are established, then used to build the prioritized service offering and product. Okay, this slide show the house of quality of the coEBN. Okay, the per method also is the important thing while doing a new design for coEBN. Okay, based on the Ki Yang, in 2005, per method concept selection is quantitative technique used to rank the multi-dimensional option of the option set. Okay, in this slide, it shows the per method in this project. So I already have design 1, 2, 3, and then we will score it by using the sign of positive and negative. After that, we will total up the scoring. For now, we move to the concept design. Okay, this one, okay, all the concept design have different mechanism, but the part is all same, which is consist of scraper, mirror, stick, and the small basket. The all design use the same material, which is the all design of scraper use the same material, which is the chrome stainless steel. Okay, so we move to concept design 1. Okay, for design 1, the material used is 1060 alloy aluminium for the basket and the stick. It have the hand gripper and the trigger. Okay, the mechanism is when the trigger press, so the iron rod turns up and push the mirror upward, and press again to have the original position of the mirror. Okay, for concept design 2, the material used is stainless steel 316L for basket and the stick. The mechanism of this design is by rotating 300 degrees of the coEBN when use the mirror, because the position of the mirror and the scraper is opposite each other. Okay, so for the last concept design, which is design number 3, the material used is ABS round pipe for the stick. The mechanism of this design is open plug mirror, because we can plug in the mirror if we want to use the mirror, and plug out from the stick if they don't want to use the mirror. This is the 3D SolidWorks. We use the SolidWorks to draw the 3D model. So according to Plan Card in 2018, SolidWorks is a mechanical design automation software package used to build part assemblies, assemblers, and drawing that take advantage for familiar Microsoft Windows graphical user interface. Okay, after we do the simulation, after we do the 3D model, we can proceed to the simulation in this SolidWorks. Okay, firstly, we go to the this software, and then we go to the general space, and click on the simulation and choose the new study. After the new study, choose the static study. The reason why we choose the static study, because of the we want to test the condition of the structural. Okay, next step is select the geometry for the design. Okay, after that, select the phase for the force to apply, which is the force is 10 Newton, and enter the amount of force to be applied in the surface. So after that, there is mesh details on the figure. After then click the run simulation, and then it will start meshing. Okay, so this figure show the scraper already mesh and mesh detail once the study already done. Okay, so after do the all things, after run the study and settle design, mesh design, then the result of the simulation will appear. Okay, now here is a summary of the simulation. Before applying the force, we can see the scraper is just like this, the initial condition, and then after the scraper we can see there's a curve um, up uh, up on the surface, because we choose the phase that will apply the 10 Newton, and then after that we can get the result of the strain, stress, displacement, and lastly, this is the model meshing. The types of mesh is triangle, triangular, shell mesh, and meshing size. That's all for my presentation. Thank you.